sir.
Okay, in our last class, we have seen the manual method of calculating the psychrometric calculations. Okay, so we also have the software so that we can easily check the different properties of the moisture. Okay, so the software is carrier psychrometric chart. Okay, so this is a carrier psychrometric chart. So I will also share the link for download this after the class. Okay. So whenever you open the file will looks like this. So you need to go for the state point here. You need to click the state point and here we need to add the point. So if you click here, we need to enter the dry bulb. So we'll go to our last class example and we'll enter the same here. So in software method, we will get the exact values. So in manual method, so there will be slight variations because we are marking it manually so that in software we will get the exact values. Okay. So here dry bulb is 104 degree Fahrenheit. Okay. Enter the same here. Dry bulb 104 degree Fahrenheit. I will enter the same. So next value, wet bulb or anything, whatever you have, so that we need to select. So here in our example, we have relative humidity. So I will take relative humidity, that is RH. So what is the value? The value is 24%. I will enter the same. So we can see the all the values here. So we have dew point temperature, that is 59 degree Fahrenheit. So dew point temperature is dP. So you can see the dP is 60.095. So here in manual we got 59. So there is a 1 degree difference. And also humidity ratio. This is the humidity ratio. The value is 77.9. Okay, so 72 we have taken. Okay. So manually we have marked so that slight variations will be there. Okay. And here next one is enthalpy, that is 37 BTU. So the enthalpy is H, it is 37.27. Okay, so like this we can take the all the values from the carrier psychrometric chart. Okay, so you can also verify your all assignment whatever you have done by using this software. Okay, so and also I will share the values that I have done manually. Okay.
Sir, in example 3,
Yeah.
this dry, dry bulb temperature is not given. So in software, we need to mention compulsory dry bulb temperature.
Yeah. Actually, in software that we need to mention the dry bulb temperature. But in general, so I have given like this, but in general, we need to mention dry bulb actually. So if you take anything, so when you are doing for the room condition or outside weather condition, so first criteria the dry bulb we know that, so that that is mandatory to enter. Okay. So for example,
Mm.
you're designing for any area in India, so that high temperature, if you search in ISHRA handbook, you will get it manually. So we no need to worry about this. So dry bulb temperature always we will get it. Okay.
Okay.
Yeah. So in software that values it is asking for the dry bulb only, so we need to follow that. Okay. Okay, so like this we can use this carrier psychrometric chart for our calculation. Okay. So next we'll go for the topic refrigeration cycle. Okay. Hi Amna, have you? I think you have not submitted the assignment. Have you done that?
Yes, I have a question. I haven't received that on my email.
Okay. What question you have?
No, I mean, I didn't receive your the assignment.
No,
Uh,
uploaded in the drive. You can download
where did you upload that?
drive in Google Drive. So daily I am uploading the videos, right?
In Google Drive. Okay, how to?
Don't have the
I
link.
no, I don't have the link. It's in the group.
Yes. I think no, I have added your mail ID so that you will get the message. Okay, no issue. I will send the link today. Okay.
Okay, okay, thank you.
Yeah. And also have uploaded the material also, history handbook and carrier handbook and also the material for HVAC. Okay. In the same Google Drive you will find out. So I will send this today. Okay. Yeah.
Okay, thank you.
Okay, so today topic is refrigeration cycle. So first we'll see what is refrigerant. So a refrigerant is the primary working fluid used for absorbing and transmitting heat in a refrigeration system. So it is a just a working fluid. So what will do, it will absorb heat at one point and it will reject heat at one point. So absorbing and transmitting heat. So it will absorb the heat and transmit to the other end. So we will see it in the clearly in the next upcoming slide. So refrigerants absorb heat at low temperature and low pressure and release heat at high temperature and high pressure. So okay, what refrigerants will do? Refrigerant will absorb the temperature at low, absorb heat at low temperature and low pressure and release heat at high temperature and high pressure. Okay, so most refrigerant undergo phase change during heat absorption, evaporation, and heat releasing condensation. So refrigerants generally goes for the phase change from liquid to gas, from gas to liquid in the evaporation and condensation process. Okay, so we will understand this refrigeration concept in the next thing clearly. So if you see this refrigerant is generally used for the all kind of air conditioning equipment. So you might have seen the split air conditioning system. So this everyone know this split air conditioning, right? In everyone home, uh, almost they have seen or they have used in this split air conditioning. If you see the outdoor unit looks like this and the indoor unit looks like this. Uh, so we will use the copper pipe to connect from indoor to outdoor unit. So in this copper pipe, so the liquid or gas, the gas which is present in the copper piping, so that we call it as a refrigerant or gas. Okay, so it will absorb heat at low temperature, that is outdoor unit. When we are transferring the sorry, when we are rejecting the heat at outdoor unit, so it will uh, the heat will be added here, and in indoor unit evaporator the heat will be rejected, so that we will get the cool air inside the room. Okay, so simply say that refrigerant is a working fluid. So it will be working in between indoor and outdoor unit to transfer the heat. By this heat, we are getting the full temperature inside the room. Okay, so and also it will undergoes the phase changes. So if you see when it reaches the evaporator, so that will be in the uh, liquid state, and when it is in outdoor unit, so that will be in the gaseous state. Okay, so that we will see one video and we'll understand it better. So after that, so before that, we have the refrigerant types of refrigerant which is used in the air conditioning system, so that we will see here. So that are classified into three types: CFC, chlorofluorocarbon refrigerants. So next one is hydrochlorofluorocarbons, HCFC, and another one is HFC refrigerants. Okay, so in every air conditioning system, so the refrigerants are not used only one type. So there are several types of refrigerants. Okay, from the development stage till these today updations. So most uh, there are more number of refrigerant was developed. So due to some environmental issues, so some refrigerants was removed, and in that place new refrigerants was developed. So these are the following types of refrigerants. So first we'll see CFC, chlorofluorocarbon refrigerants. CFC, we have uh, five types of refrigerants, that is R11, R12, R113, R114, and R115 refrigerants. So these are the almost phased out refrigerants. I think in 15 years to 20 years back, these CFCs was used regularly. But in today's world, these all are phased out refrigerants. Okay, next one is HCFC refrigerants. HCFC are two types, R22 and R123 refrigerants. So these hydrofluorocarbons, uh, major drawback was the depletion of the ozone layer. So due to this R22 gas, so when it's leaked in the environment, and also if it is used, so so that these properties of the gas is affecting the ozone layer. Okay, so mainly this R22 was banned in the recent years. So people who are using the old equipment, so they are purchasing and using, but in nowadays the R22 is not using by any industries. Okay, so these also the ruled out HCFCs, and current trend was the HFC, hydrofluorocarbons. So if you purchase any equipment in recent days, you only see this uh, following refrigerants, that is of R134A, R404A, R407C, and R410A. Okay, these are the hydrofluorocarbon refrigerants which is used in the current industry. Okay, so these are the different types of refrigerants. Okay. So R is nothing but refrigerant. 22 is the code given for the each refrigerant, like 22, 123, 11. Okay. So this is a vapor compression cycle. So think you if anybody is from mechanical background, so they might have know this compressor refrigeration cycle. So and also we will discuss. So this is a main topic for to understand our HVAC system. So remember that every HVAC equipment in our industry, like air conditioning equipment, that will run using this vapor compression refrigeration. If you take chiller, AHU, split AC, cassette AC, any type of units, so that will run based on the vapor compression cycle itself. Okay, so this is the single line drawing. So whenever you are representing in the single line drawing, you need to show like this, and this is the image, like for better understanding how the compressor, evaporator, condenser will looks like this. So I have shown in this image. So this when you compare with any indoor unit. So that here I have compared with outdoor split AC so that you can easily understand this. Okay. So we also have the one video so that we will understand it better. So first we will see the single line drawing. Okay. So here we have compressor, condenser, expansion, and evaporator. Okay. So I will tell here. Okay. So first the process will start from the compressor. So you can see 1 to 2, 2 to 3, 3 to 4 and 5 till the 8 evaporator. Okay. So compressor will be in the outdoor unit. So let us take the example as a split AC only. So the split AC comes with an indoor unit that we will keep it inside the unit room. Outdoor unit we generally hang it outside the environment, outside the room. Okay. So in outdoor unit, so we will have the compressor and the condenser and also the expansion valve. Okay. So these three will be in the outdoor unit. Okay. So next we have the evaporator, that is inside the uh, indoor unit. So not evaporator and also the expansion valve, these two will be inside the indoor unit. Okay. So when the refrigerant, so the refrigerant will goes in this copper tubes. Okay. So you can see the 1 to 2 to 3, these all are the lines, that is a copper piping lines. Okay. So when the refrigerant enters into the compressor, so the compressor work is to increase the pressure and temperature of the fluid gas. So when the refrigerant enters into compressor, the compressor will increase the temperature and pressure of the gas. So the high temperature, high pressure compressed gas that will enter into the condenser. So this is called a condenser. So if you see, compare this is the outdoor unit, this is a fan we have, and also the coil backside of this. So that we call it as a condenser. Okay, so the condenser, we have the like coil inside this. So when the refrigerant flows in the circuit of the condenser, so the fan is continuously rejecting the heat. So due to this, the temperature of the gas is reduced, so that after the condenser, so the high temperature and high temperatures, the heat is rejected, but the temperature and the pressure of this gas is still at the high point, so that the condenser, after exiting the condenser, so that it will goes to the expansion valve. So that if you see, after the compressor, it has the high temperature, high pressure, but the state is in gaseous state. Okay. So I will write it down here so you understand better. So at this stage, after this stage, it will be like, after this stage it will be high temperature and high pressure. Okay. So after going to the condenser, so only the heat will be rejected and it will convert gaseous into liquid state, but the temperature and pressure is high. So here I will write it as a gaseous state. Yes. And after the condensation, so it will be in liquid state, and also the temperature is high temperature and high pressure. Okay. But it has undergone the phase change, so the gas is converted into the liquid. Okay. after the condensation. So after condensation, it will goes to expansion valve. Expansion valve work is to the fluid which is coming from the condenser. So it will expand here. So when it expands, so the pressure and temperature will be reduced here, so that it will the temperature of the refrigerant will be converted into low. So here I will enter low temperature and low pressure. Here that will be liquid plus solid, liquid plus gas, L plus. So here if you see, the state is liquid plus gas. Okay. So here we have liquid state and here we have gaseous state, but after the expansion valve, it has the two states, that is liquid plus gas. So the liquid plus gas will enter into the evaporator. So the evaporator is nothing but the our inside split AC. So if you take the example of a split AC, so that we will have one blower. So the blower will blow the air in on top of this coil. So we will get the chilled air inside the room. Okay. So after we have the sensing bulb here. So sensing bulb will be attached to the expansion valve. So with this sensing bulb working is whenever the temperature of the fluid is high, so it will sense. So when, for example, in inside of the room, we are not getting the proper cooling, so that if we have more number of people inside the room, so we are not getting the cooling but so this sensing bulb will sense the refrigerant temperature and it will understand that there is more requirement of the cooling. So what will do, it will open the expansion valve accordingly the temperature. So if the temperature is not achieving, so that sensing bulb will give us sense to the expansion valve, so that expansion valve will open or close partially and it will send the high more refrigerant. So when the more refrigerant will enter into evaporator, so we will get the required cooling rate. Okay. So that is a sensing bulb work. And after this, we call this line as a suction line. So after entering the uh, compressor, the state should be like temperature will be high. Okay. So low pressure will be there, and also the state will be gaseous state. So okay, after the evaporator, 100% that will be converted into gaseous state. Why? Because if it is not converted, the compressor will going into it will goes to damage. So why? Because the compressor, when the fluid is entering into compressor, the it should be in gaseous state. If it is liquid state, the compressor will going into damage. So that it is not possible 100% after the evaporation, the gas will be converted into gaseous state. Okay. So this is the working of the refrigeration cycle. So I will explain it one more time in a simple way. So first I will show you the liquid and gas suction line. So from evaporator, from indoor unit to outdoor unit, so this line we call it as a suction line. So okay, remember these terms, it is very important. And also the supply side from condenser to the expansion valve, so that is evaporator, that line we call it as a liquid line. Okay, so these are most important liquid and suction line. So somebody will call it as a return line or supply line, but in technical terms we need to call it as a supply line as a liquid line and a return line as a suction line. Okay, so we'll also use it in our upcoming classes, but don't forget this lines. Okay. So here I will uh, show the working of the refrigeration cycle. So in a simple way. So first the will go to compressor. So what will do, the compressor will increase the pressure and temperature. So the state is gaseous state. So after this will the gas will go to condenser. There the heat will be rejected. The gas is converted into liquid state, but the high temperature and high pressure. So the gas will go convert into liquid. That liquid will goes to expansion valve. In expansion valve, the liquid will goes for expansion, and after the expansion, we'll have low temperature, low pressure, and mixture of liquid plus gas. So it will goes to evaporator, and in evaporator, we have the uh, fan which is blowing to the evaporator, so that heat will be the chilled air is sent inside the room, so that after the evaporator, so the gas will liquid plus gas will converted into gaseous state, and it will have high temperature and low pressure, so that will enter into the compressor. So this is the working of the refrigeration cycle. Okay. So very important is the state, the gaseous state, where this gaseous state and where the liquid aligns, and the temperatures. So that is very important. So interview point of view, so they will ask to mention the different where we call it as suction line, return line, liquid line, and also the high pressure and low pressure areas, and the liquid line, and the uh, where the refrigerant will be in gaseous state, where it will be in liquid state, that will be asked. So okay, so practice well. So continue. So we have a video here, so you can easily understand this. So I'll open this video. So this is a compressor, condenser, expansion, and evaporator. So you can see the working of this refrigeration system. Okay, so after the compressor, you can see the working of the compressor also here. So the gas will be at high pressure, high temperature, vapor. So vapor nothing but the gaseous state, we can also say. So after that, it will goes to condenser. So we will see what is the state after the cooled from external source. So nothing but the fan which we are using to reject the heat. So after the condenser, you can see the high pressure, high temperature, but the state is in liquid. To see the difference here, that is vapor, and after the condensation, that is liquid. Okay, vapor nothing but the gaseous state. Can also call that as vapor state. And expansion valve. So after the expansion valve, you can see the fluid is expanded, so that the gas is converted. So this liquid will have the below properties, that is low pressure, low temperature, but is mixture of liquid plus vapor. Okay. So the state of the refrigerant is liquid plus vapor. So that will enter into the evaporator. Okay, you can see after the evaporator, the low pressure vapor will enter into the compressor again. Okay, so like this we will understand the better the how what is the liquid state, vapor state, and also the low temperature and high pressure states. Okay, fine. So next, these are the different types components of the refrigeration equipment. So the first one is compressor. So we'll see how the compressor will work. A compressor is a mechanical device that increases the pressure of gas by reducing its volume. So when the gas enters into compressor, it is a device, mechanical device, so that it will increase the pressure of the gas by reducing its volume. When it's when we reduce the volume of any gas or air, so what will happen? The pressure will be increased. So there are primarily four types of compressors used in air conditioning industry. That is reciprocating scroll type, helical rotary or screw type, and centrifugal compressor. So these are the four types of compressors we are used. And the condenser. The condenser is a heat exchanger that rejects heat from the refrigerant to air. So we have seen that in outdoor unit we will have one fan and a coil circuit. So it will reject the heat from the refrigerant to the air. To remove heat from the refrigerant, to condense the refrigerant from vapor to liquid. So we know that after the condensation process, the refrigerant is converting from vapor to liquid. Okay. Next one is expansion device. An expansion device is used to maintain a pressure difference between the high pressure and low pressure sides of the system established by the compressor. So after the condensation, it will goes to expansion. So after the condenser, what is the pressure is high pressure, and after the expansion, that is low pressure. So that it will maintain a pressure difference between the expansion, between the condenser and the evaporator. So this is the expansion valve. So this will be of high pressure, high temperature. So after this, it will be of low pressure and low temperature. So it will maintain that pressure. And also to reduce the pressure of the refrigerant and to regulate the flow. So we have seen this by using the sensing bulb and expansion valve. So based on the sensing bulb, it will regulate the flow of the fluid also. Okay. And next one is evaporator. The evaporator is all heat exchanger that transfers heat from air, water, or some other cooling liquid refrigerant. So, okay, so it will transfer heat from the air, water, or some other cool liquid refrigerant. So here in our example, that is cool liquid. So if you go for chillers, so that is of water cool chiller, air cool chiller. So there we will use different evaporators. So here we have used cool liquid refrigerant as a medium. Okay. So this is the refrigeration cycle. I think everyone has understood. So if you have any doubts, you can ask me.